we're going to take a look at hypothesis testing as it relates to the decision matrix. We're going to keep this really simple to begin with. We're going to have sample sizes of 1,000, which means not much variability in those sample means around what you would expect based upon the null hypothesis. In addition, if there is a treatment effect, it's going to be large. So that'll make it easier to spot. I'll go ahead and click Draw Samples. We have 10 samples that are going to be drawn from this population here. That has a mean of 24 and is slightly skewed. The dashed red line represents the population mean, what we expect based upon the null hypothesis. And the solid green line, that's the sample mean. You can see that by having samples of size 1,000, that there's not a lot of variation in these sample means. And as we look at these, except for sample 9, as we look at these, they're almost identical. For sample 9, we see this huge leap, this huge difference between the null distribution population mean and the sample mean, consistent with a treatment having taken place here. So head on over to where we get to make our decision, and I'll say, I think it was sample 9. Now what we're shown for each of these samples is what was the p-value if you did a two-tail single sample t-test. So for samples 1 through 8, p is greater than 0.05. For sample 10, p is greater than 0.05. But for sample 9, which we saw looked really suspicious, the p-value was less than or equal to 0.05. And what that's saying is, you know what, if the null hypothesis is true, this is really unlikely. Really small probability that you would get this from just random selection. And I agree. So here we go. Go back up and choose to reject sample 9 with p-value less than or equal to 0.05. And we have, well done. You applied the decision rule correctly. P is less than or equal to the alpha level by selecting sample 9, which was 23.81 due to random selection, plus a treatment effect of 4.84. According to the hypothesis decision matrix, given that you 1, chose to reject the null hypothesis, and 2, this was a sample affected by a treatment, this was a correct outcome, rather than, for example, a type 1 error. All right, that was pretty good. Let's go ahead and do this again and quickly look at our outcomes. And sample 7 is really sticking out there. But let's say that, here I'm going to go and I'm going to choose my response. And sample 7 is less than 0.05. And I don't pick it. I say none of the samples. So it says you chose none of the examples, but at least one sample had a p-value that was less than or equal to that 0.05. So remember, it reminds us, when p is less than or equal to 0.05, reject the null. So we have a decision rule. We don't have to really give this a lot of thought. We don't have to actually eyeball each of these samples and take a look at what does the sample mean compared to the null hypothesis. I mean, I recommend doing it. But it all comes down to applying a very simple decision rule. If the p-value is 0.05 or less, and all the requirements for the test we're doing have been met, then we reject the null. All right, let's go ahead and work with a sample size of 25. 25 is a more realistic sample size that we might work with out there. And we'll keep our effect size large for now. And I'll say draw sample. And notice now that we have more variation than we saw before. And it looks like this variation, except for maybe sample 8, is due to just normal random selection. But sample 8, it looks like something unusual is going on there. So here we go. We take a look, and we see that, yes, indeed, for all these samples, the likelihood that it would be the result of just random selection is much higher than 0.05. And that's true. If, however, we take a look at sample 8 here, it says the probability you would have gotten sample 8 from just random selection, it says is very unlikely. And yeah, this is probably a result of a treatment. So we'll go ahead and we'll pick it. And it says, well done. We applied the decision rule correctly, and we made a correct decision. So it's a correct outcome there. We'll do this again. But this time, actually, let's go with the medium size effect. So now we have a lot of noise because our sample size is smaller and our effect size isn't particularly large. It's medium, which means it's about half of a standard deviation. So our standard deviation here is 6, so we might expect a treatment effect of like +3 or treatment effect of -3. So I'm looking at this, and nothing is really standing out to me. Maybe sample 3. But let's look at our decision rules. And decision rules, yep, they're all like, look, this could easily just be the result of random selection. So none of the samples. It says, well done. You applied the decision rule correctly by selecting none of the samples. And according to the decision matrix, given that you chose to retain the null and none of the samples were affected, this was a correct outcome. Awesome. Go for it again. Sample 2 is looking mighty affected there. And so we'll go ahead and look at our p-values. And yep, for sample 2, the p-value was less than 0.05. It was like, yeah, not likely to be due to just random selection. Okay, so come on over, check this out, and see how well your experience is with applying the decision rule and with making correct decisions. And also, hopefully sometimes you'll get some type 1 and type 2 errors just to see what those are like. Take care.